Hi, thank you for watching this video tutorial about JNI. I will show you how to get started with this framework using Eclipse and Visual Studio. I will present you a few examples that cover the most common uses of JNI. We will see how we can debug JNI application, how the native side can crash the JVM, and also we'll talk quickly about memory management. Let's start with creating a project in Eclipse. We'll call this project JNI example. Now that the project is created, we'll add a class to it. We'll put this class in a package CodeBazaar example, and we'll call it bin. We're adding two members to this class, a string and a byte array, with the getters and the setters. This bin will be exchanged between the Java program and the native library. We overload the toString method. We will use that later to log the content of the bin. We are now adding a new class and we'll name it JNI example. This class loads the native library. To do so, you can call system load library with the name of the DLL as parameter. We are now adding 4 native methods that will be later implemented in the DLL. You need to declare them with the modifier native. Call Java method will call from the library a method in this class. Create and return bin will create a bin in the library and return it to the Java program. Modify bin takes a bin as parameter and return nothing. Crash the JVM will just crash the Java virtual machine. We are now adding the method print something, which will be called in the library by call Java method. And we are also adding 4 methods to run and log our examples. Run example 1 calls call Java method. Run example 2 calls create and return bin, then it logs the content of this bin. Run example 3 instantiate bin, then fills it with some data and calls modify bin, and it logs the content of this bin before and after. Run example 4 just calls crash the JVM. So now let's create a main class that will be the entry point of our application. We instantiate the class JNI example we just created, and we call the 4 example methods. We keep the first commented as it crashes the JVM. Now let's create the DLL. So in Visual Studio we create a new project called JNI example library. We define we want a DLL and an empty project. We can now add a C++ file that we will call JNI example library. The JDK offers some tools to help with the development of JNI applications. So here we are going where the JDK is located to find them. Here they are, Java H and Java P. Let's take this path and we'll save it in Eclipse. So Java H can be used to generate a C++ header file with the signatures of the native methods we define in a Java class. We need to point it where the class files are, and we want here to generate the file, the header file, in the same directory as the C++ file we already have. So I use -d to specify its location and -JNI to specify the class we are working on. In our case, Code Bazaar example, JNI example. So before we check the result, let's look at our 4 native methods again. I am now adding the generated file to the project. You can notice the file name matches the full class name. The method signature also matches the package, the class, and the method name as defined in the Java class. However, there is a compilation issue here, and the reason is the project cannot find jni.h. To fix this, we'll configure the properties in C++, general, additional include directories. What we need to do is to add the 2 directories, include and include Win32 from the JDK. This is where jni.h is located. So here you go, it's not complaining anymore. Now we can include the header here. We copy the signature of this method and we will make it a method. JNI env is a pointer to the JNI environment, and JObject represents this in Java. So in this case, this is the instance of JNI. GetObject class gives us a handle to the class JNI example. GetMethodID gives us a handle to the method print something, and this is the signature to this method. And finally, callVoid method executes the call to the Java method. Finding the method signatures can be pretty cumbersome. That's why I advise you to configure Java P in Eclipse. It takes -s with the full class name and it prints all the signatures. Here V stands for void. Now we are adding create and return bin. Here we find the class bin and the constructor. Init is the name for a constructor which returns nothing. With new object we instantiate the bin new string UTF creates an instance of a string in the JVM. Here we find the setter for the string in the bin. We set it and return the bin. Now we are implementing modify bin, which takes a parameter bin. Again, we find the class for this object bin, and we find the setter for the string member. We create a new string and set it. We'll do the same thing for the byte array. We will copy these values with set byte array region, find the setter, and call it. The method crash the JVM tries to create an array of doubles which is larger than the memory in the stack, which generate a stack overflow. We are now building the solution. And we can see the build succeeded, and we can find the DLL in the debug directory. The DLL file name must match what we specified here, and the Java program needs to know where the DLL is. So we need to configure it before we run the Java application. So here we find the main in the class and add an environment variable path, and we will add this directory to the path. Let's look at the logs now. In run example 1, we can see that print something was called from the DLL. Run example 2 received the bin from the DLL and printed its content. Run example 3 shows the string member has been modified from hello to world. Okay, so now we can unleash the monster. And we can verify we crashed with an exception stack overflow, and it happened in our DLL. To debug our application, we can set a breakpoint here and start the execution in debug mode. We set a breakpoint in the DLL and attach to the Java process. We continue now the execution of the program, and it stopped in the DLL. If we execute the next line, it crashes. And we can find the same logs. So if we change the size of the array to something more reasonable, we can recompile the solution. A new DLL is generated, and now we are able to run the application without crashing. So let me summarize what we did. We created and debugged a program using Eclipse and Visual Studio. We have seen how a bug on the native side can crash the JVM. This can be a serious issue if you want to integrate your DLL on the server. Imagine that a user executes a bug piece of your DLL, your whole server will go down, and your website won't be available until you restart it. Regarding the memory management, in our example, we don't have to free any resources. All of them were created and manipulated within the JVM, so the garbage collector took care of it. You will have to free explicitly your resources if you use methods such as getStringUTFChars or malloc. Well, thank you for watching this video, and I hope it will help you. Thank you, bye.